In today's video, we're going to be talking about solving one-step equations. We did some of this last year, so I'm just going to do a quick review of this so we can get into some more complicated equations. Remember, when we're solving equations, we need to show our work and we need to use the properties of equality. We're going to start by using the subtraction property of equality to solve this one-step equation here. Remember, the subtraction property of equality tells us that if we subtract something from one side, we also have to do it from the other side. And if we do, then the equation will remain in balance and true. The reason we're subtracting 2 here is because, remember, our goal is to isolate this variable and make sure it's all alone on one side by itself. In the beginning, this plus 2 is here, and we want to get rid of that. So getting rid of a plus 2 is easy if we just subtract 2. So when we do that on the left side, we end up with x all by itself, and on the right side we end up with 7 minus 2, which is 5, which I'm sure you could have done in your head. But remember, we're practicing showing our work, because when we get to more complicated problems, we need to make sure we know the rules so we can solve them. So using the same property, subtraction property of equality, we can see we're going to subtract both sides by 3.2 again. Slightly more complicated. In this case, the left side is going to be easy. We're going to end up with x because we subtracted 3.2 specifically to get rid of this, so we know that it'll leave x. This here, we got to remember when we're subtracting decimals that we have to line up the decimal. Any empty spots, put some zeros in there, and then we just make sure everything stays lined up. Decimal gets dropped right down to the answer. Let's borrow. And so we end up with 9.443 is the answer. In this next problem, we're going to be using the addition property of equality, because to get rid of a minus 7, we need to add 7. And remember, we have to do it to both sides to keep the equation in balance. On the left side, we'll end up again with y all by itself. On the right side, 10 plus 7 is 17, and we can check our answer. 17 minus 7, sure enough, does equal 10. So that was kind of a simple one there. Get one that's a little more difficult here, but not too bad. Again, we have this subtraction of 27. We need to do the inverse operation. We need to get rid of that minus 27 by adding 27. Again, the addition property of equality says we have to do it to both sides. On the left side, we're going to end up with this m all by itself. On the right side, we have negative 34 plus 27. If you picture that on a number line, we're way over here on this negative 34. 0 is 34 spots away. So if we add 27, we're not quite going to get to 0. We're still going to be on this negative side here. And it looks like we're going to get a negative 7. So negative 7. Let's move on to another problem. So in this problem, 2 is being multiplied to x. So the inverse of multiplication is division. So we need to divide both sides by 2 in this case. So we're going to divide both sides by 2. What happens here is the 2's cancel out on this side, which was our goal, leaving x all by itself. Technically, when 2 divided by 2 is 1, so we get 1x, but we don't need to put the 1, we just write x. And then 8 divided by 2 is 4. And we can double check our answer. 2 times 4 is 8. That was a pretty simple problem. This one won't be quite as simple. Negative 6 times something equals negative 22. Well, that something is not going to be a whole number, and that's okay. We chug along just like we normally do. We need to divide both sides by negative 6. On the left side, the negative 6's cancel out, or negative 6 divided by negative 6 is 1, leaving us with our x. And then on the right side, well, negative divided by a negative is a positive, so right now we can start by just writing this. Rather than grabbing a calculator and doing figuring out what the decimal is, or even rather than doing long division to figure out what the decimal is, it's okay just to reduce this fraction and be done. This is a completely acceptable answer, as would be this. Either one of these are completely acceptable answers. What I normally do is answer like this when it's just a calculation problem, and I would consider answering like this, and I probably would answer like this if it was a word problem. Okay, so remember, I don't want to see decimal answers here. Leave it as a fraction. It's going to make your life easier, and since I don't require the long division in this case, don't do it. Okay, that looks like the same thing. I don't know why that happens, so we'll go on to this problem. Here we have our variable being divided by 5. The inverse of division is multiplication. So dividing by 5 is the same as multiplying, or sorry, the opposite would be multiplying by 5. So we're going to do that to both sides. When you're dealing with multiplying by a fraction, sometimes people like to make this a fraction. Over here it wouldn't be necessary. Either way, 5 over 1 and 5 are the same, so you can just show them differently if you want to do the fraction step. Now 5 divided by 5 is a 1, leaving us with 1n on this side, or just n. And then 10 times 5 is 50, and we can check that 50 divided by 5 is 10, so we're good. This one is a little more challenging, but again, we use the same technique every time, so it doesn't make it any more challenging. It's just that we can't do it on our heads. So we're going to multiply by 2.3 to both sides. As usual, that's going to cross out the numbers over here, leaving us with n. Over here, we're going to have to do a little more work. 2.3 times 0.6. Nothing we can't handle. 6 times 3 is 18. 6 times 2 is 12. Adding the 1. Now here we have 2 digits after the decimal place, this one and this one. So our 138 actually becomes 1.38, which makes sense because this is about half, and so half of 2.3 is going to be close to 1.38. So that does make sense, and that is our answer, and that is the end of the video. Thanks for watching.